Just wanted to just go over a really, really key concept. And I'm going to go over it informally and then I'm going to go through it formally. So, independent versus conditional probability. So, independent probability means that two events are not related. So, if one event happens, the probability of the other event is unchanged. I'm just going to show it the difference here between conditional and independent probability using this jar. And imagine that I can actually draw, and these are marbles, and these marbles seem to be floating actually. So this is a magic jar of marbles. So I have this makeup of marbles: 2 black, 3 red, 1 green, 3 blue, and 9 marbles in total. So I put my hand in, I close my eyes, I put my hand in, I choose a marble at random, and I choose a red marble. And I take that red marble and I put it on the table there, so I can't put my hand in next time and pull that same marble out. Now, is the probability changed? And the answer is yes. Before I took the red marble out, the probability of getting a red, there were 3 reds, and there were 9 marbles in total. So 1 in 3 was our probability. After I took the red marble out and didn't put it in, so the technical word is without replacement, how many red marbles are left? Now there's 2 marbles, but there's only 8 marbles left because one of them is missing. So 2 over 8 is the same as quarter. Those probabilities are changed. Therefore, it's a conditional probability. Okay? All right. Let's get rid of that marble and let's put it back. I'm going to put the marble back. Rub this out here. All right, now I put my hand in and I grab the green marble. Okay, I take that green marble, I put it on the table there. Okay, what was the probability of getting a green marble before I took it out? So the probability of green, well, there was 1 green marble, there were 9 marbles in total. Okay, so then I'm going to take that green marble there and I'm going to put it back into the jar. So it's with replacement. Now, what's the probability of getting a green marble? Well, the probability of a green marble is 1 green marble, and there are 9 marbles there again, so it's the same. So with replacement means it's independent. Okay, the marbles are not, they're not talking to each other. The red marble here is not saying to the blue marble here, I've come up enough tonight, it's your turn now. This black marble here is not talking to the green marble saying, hey, come on, give us a go. They're not talking to each other. They are independent. Theoretically, I could keep putting my hand in and getting green, 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 green. You could theoretically do that. It would just be really, really improbable. All right. So, what is the probability in formal terms, and how do we define these terms? And what we need to do is we need to do a little bit of the shorthand, the algebra of independent and conditional probability. So probability, if one event is conditional on the other, that's how we would write it. You need to get used to this shorthand. What that means is that what is the probability of getting A given B has already happened or is happening? Okay. So here, the probability of green, given that we got a red last time and didn't put it back. Okay. So this would be the probability of green. How many greens are there? Well, there would be green given red. There is one green and there are 8 marbles left because the red marble has been taken out and not put back. Okay, that's conditional. The conditions of probability change given a previous event. Now let's look at independent probability. So a test for independent probability is there's actually 2. Probability of A, and the proper symbol is B, but I've often seen it in the NCEA books as A and B, is going to be equal to the probability that event A happens times the probability that B happens. Okay, so that's a formal definition. There are 2 other things that would come from that, and that is the probability of A given B would be equal to probability A, and probability of B given A is equal to the probability of B. So in other words, if you kind of go through it in your head there, these are equivalent statements. So what this says is the probability of getting A is the same as the probability of getting A, even if B is in the equation there. And here the probability of getting B is the same as getting probability of B, even when A is in the equation there. Okay, so back up, see if you can get your head around it. I'll explain it using an example. So the probability of green and then probability of red with replacement. Okay, so the probability of getting green, we know this has been 1/9. We put the green back, and then the probability of getting red is 3/9. So the probability of getting green, then getting red, is going to be equal to 1/9 times 3/9. Right? There is one other implication of that, and that is in the sample set. If 2 events are independent, the number of ways that an event can happen is going to be equal to the number of ways that the first event can happen times the number of events that the second event can happen. And we already saw that with the example of the dice, or the die or the dice, I don't care, where we're looking at the outcome of 2 die tosses. There's 6 on each dice, so there are 36 possible outcomes. 6 times 6. Okay. Now let's look at mutually exclusive events. So mutually exclusive, I'm going to say ME just for short, is when 2 events cannot happen at the same time. Cannot both happen. Okay, so the probability that the All Blacks win the next World Cup and the probability that the Springboks win the next World Cup, these are two mutually exclusive events. Okay, only one team can win the World Cup. They don't share the World Cup. If there isn't a clear winner, if the ties are scored after 80 minutes, they have extra time. What they do after that, I'm not sure. I guess they have extra time until there is a winner. Right? So in this case, probability of blue, getting a blue, and probability of getting a red, given we put our hand in, these are mutually exclusive events. Okay? You can't pull out the blue and the red. You can only pull out one at a time. Okay? You could have another one, but they are mutually exclusive events. Both of these events cannot happen. At most, one of them can happen. Lastly, we're going to deal with complementary events. And this is really a kind of a special case of mutually exclusive. And complementary for us means that there are two events that can happen and only two events that can happen. And that both events are mutually exclusive. And one has to happen. Okay, so in this case, if we put our hand in, and I've taken all the other marbles out of the jar, the probability, the event of getting a blue marble is complementary to getting the red marble. I'm going to run it through. So getting blue or red, there are two events. Yeah, there are only two events. So we can't put a hand in the jar and pull it out and have a Rubik's Cube or a chocolate milkshake. There are only two events, red and blue. They're both mutually exclusive, so we can't put a hand in and grab both of the marbles and pull it out. Not allowed. One of them has to happen. If we put a hand in and we feel around until we find a marble and we pull that marble out, then one has to happen. If the All Blacks are playing the Springboks in the World Cup final, one of them has to happen. One of them has to win. Only one of them can win, which we already established. So that tells us that the probability of red plus the probability of blue, when you add them together, it equals 1. So the really we're saying the probability of reaching in and getting a marble is 1, because we have to reach our hand in and get the marble. If the probability of getting red plus the probability of getting blue is like 0.9, that means there must be at least some third option that we don't know about, and that would be bad. That would be wrong. We're going to be going over these a bit more, but this is the kind of theory that you need to have down pat. So if you need to watch it again or consult some other source, I might put some links in the description. Look those up. You need to really be in command of these concepts.